Hi guys. So, day before yesterday, we completed the photoelectric effect. We understood that how photons work and what is the effect of coming sunlight on a metal plate which can leave electrons and which can conduct photoelectricity. You may have heard about all these things while you may have come in contact with solar energy and conversion of solar energy into electrical energy. Now we'll talk about photons count emitted by a source per second. So number of photons emitted by a source per second. So let us consider that this is the source and this source has a power P. Okay, this source has a power P. So if power P is there, this is equals to energy upon time. So energy per unit time is power. So even you can write energy is coming from photons, so photons energy is quantized. Here we need to write it total energy of photon is quantized. What do you mean by quantized? That every one photon will have same energy. So if there are n number of photons, energy will be n into energy of one photon. So here we'll write n into energy of one photon divided by time. Now it is per second, so time is 1. So n into energy of one photons, which is coming in 1 second. Okay, so that is power. So now number of photons is n. This is energy. What we can write here is n is equals to power into time upon energy of one photon, right? Power into time upon energy of one photon. Here if we consider time as 1 second, it will become what? Power upon hc by lambda. So p lambda upon hc becomes your number of photons. Okay, now we'll come to intensity of light due to a light source. So what is intensity? I'm sure we all have heard about it. Intensity is the energy crossing per unit area per unit time perpendicular to the direction of propagation, right? So now we'll see here per unit area per unit time, but perpendicular to the direction of propagation. See this diagram here. This is the power source with power P. So this is giving light energy. Now it is going straight, right? This source is not a point source. This is a source which is diverting a light just like a torch. Okay, it falls on this surface area which is called as A. Okay, so on this surface area this light is coming and falling. And what is intensity? Intensity is energy by time into area. Now energy by time is power upon area. That becomes intensity, right? Now power is n into energy of one photon upon area in 1 second. So we'll write time here. In 1 second it comes like this. So this becomes the intensity of light which is coming on, falling on that A surface area, which you can write n into hc by lambda A t. Like this we can write this intensity. But now we can consider one more point. This is where we were putting a straight beam of light on a surface area. Now if we consider the second diagram which is given here, the second one is a point source. So we are trying to find out intensity at this point A. We are trying to find out intensity at this point A. So the source is here, power is P. Source is here, power is P of this source, and we are trying to find out the intensity here. So this source will emit photons in all directions. It will emit energy in all directions. So if it is emitting energy in all directions, photons will go in all directions. So there will be a split up, right? What we can write it here as intensity is equals to, we wrote power by area. So power is P, the same what we have written, because source power is P. Area is how much? This entire energy is spreading upon which area? It is spreading upon a sphere, because here we can see only 2D diagram. But in reality the diagram is a 3-dimensional figure. Means a point source will do what? It will spread energy in all directions like a bulb, right? So it will become a sphere. So what is the surface area of a sphere? Surface area of a sphere is 4 pi r square. Now this is at a distance r, which is given here. So this power becomes, this intensity becomes P upon 4 pi r square. Okay, got my point? Let's come to the next topic, which is photon flux. Now what is photon flux? Photon flux is the number of photons incident on a normal surface per second per unit area. So now when you talk about number of photons, so photon flux is denoted by phi. It is intensity, because it is asking for what? Number of photons incident on a normal surface per second per unit area. So it is per second per unit area, that means intensity is there, and intensity divided by energy of photon. That will give you the number of photons which are incident on a normal surface per unit area per unit time, I lambda by hc. You can write photon flux as I lambda by hc. Okay. Now we come to an important point. Now if you guys have gone through that movie, which one? Chandrayaan, Mangalyaan. Which movie we made? Akshay Kumar's movie? Yeah, Vidya Balan and Akshay Kumar. So in that movie, if you have listened to them carefully, the probe which they made, they said something that sunlight's intensity will guide this probe in the desired direction. So how sunlight can guide this probe in desired direction and can increase the speed of the probe? Via radiation force or radiation pressure. So if you can see here, the force experienced, yes, we'll increase it. The force experienced by surface exposed to radiation is known as radiation force. So the force experienced by surface exposed to radiation is known as radiation force. So now consider this, that there is a light source with power P. It is throwing a light on a black body on a surface area A. Now if you know, and if we know, we all know this, black bodies absorb all the light, right? They emit also energy, but when the temperature of the surrounding is lower as compared to their temperature, then they emit all the energy. But if it is not, then they absorb all the energy. So there can be two cases, rather three, but we'll discuss two. First case is the whole amount of radiation is absorbed by the surface. So the absorptive coefficient is 1 and reflective coefficient is 0. Case 2 is when the whole amount of radiation is reflected by the surface. So absorptive coefficient is 0, reflective coefficient is 1. Now one very important thing which we need to remember to understand this, that how all these things happen, is by Newton's second law. By which? Newton's second law. Force is equals to change in moment, rate of change of momentum basically. Force is equals to dP by dt, that is rate of change of momentum. So here if you consider in the case of only absorptive coefficient, there is no reflective coefficient, so we can say that the momentum, okay, P I am writing, momentum is given by E by C or H by lambda. So if there is a photon with momentum H by lambda coming to a body and it is getting absorbed, so delta P, change in momentum, this was initial Pi, P final is, because it got absorbed, P final is 0, so change in momentum is Pf minus Pi, that is equals to minus of H by lambda or E by C basically. So this is minus of H by lambda or E by C, but that is we are talking about one photon. This is all we are talking about, one photon, right? So there are n number of photons. According to the power, there are n number of photons. So if n number of photons fall, I'll remove this. Yeah. If n photons fall in 1 second, what happens? Total change in momentum is total delta P is equals to n into delta P, which is equals to n into h by lambda, right? Now one important thing here, n is the number of photons. We initially did this in the start. N is power upon, what is n? Power upon energy of one photon into delta P, which is h by lambda. Now P upon EP is what? hc into h by lambda. H and h got cancelled, lambda and lambda got cancelled. So finally what we get is, here we'll write it, finally what we get is P by C. Finally what we get is P by C, or what we can write it as, power is what? Intensity into area. Power is what? Intensity into area by C. So if the coefficient is only absorptive coefficient, then all the photons will get absorbed, and the change in momentum, total change in momentum, that is force. Total change in momentum is what? Force. So force will come out to be IA by C. Now you can tell me one thing. There is one delta P here which shows a negative sign, right? So why it is showing a negative sign? Because we are considering here about the photon, and what we need to find out is the force on the body. So the force on the photon will be opposite to the force on the body. That is why at the last we have written force as IA by C or P by C directly without putting the negative sign, because this negative sign will be for the photon, not for the body which is absorbing it. Got my point? Let's come to the next part. Next part is what? When we are only and only reflecting. Now if we are reflecting, in case of reflection, what happens? In case of reflection, Pi will be equals to h by lambda. Pf will be equals to minus h by lambda, because it will just strike it and go back in the opposite direction. So delta P is minus 2h by lambda. Delta P becomes what? Minus 2h by lambda. And now to find out the force, which is delta P by delta T, which we will write it here as minus the force, but this is again the force we are talking about is the force which is there on the body, not on photons. So delta P by delta T. So delta P will be what? Number of photons into delta P of one photon upon delta T. Number of photons will be what? Power upon energy of one photon into delta P by delta T. Now we'll write power as PW. Okay, we'll write here power as PW. Here also we'll write a power as PW, because momentum is also been represented with the symbol P. So we are writing power here as PW. So PW delta P by T, again we'll write it here. Then power, let's write it like this: P upon P into lambda by HC multiplied by minus 2h by lambda. So it comes out to be 2p by c. Oh, now because we are writing it for the photon, writing it for the body, not the photon, so we'll write it as plus. So this will be plus. So 2p by c, or it will be equal to 2ia by c. So this is the radiation force. Now if you want to find out pressure will be, okay, again Pressure is also been represented with P. So we'll write pressure as complete pressure. Oh, we removed something around from here. Oh, sorry. This will be a multiplication sign. Yes, multiplied by H by lambda. And here we were writing pressure. So pressure is equals to force by area, that is equals to 2IA by CA. Area and area got cancelled, so 2I by C. That is the pressure, and force we already found out. Okay, so that is how radiation pressure and radiation force works. Yes, so now we come to the most important part of this chapter, that is questions practice. Exactly. Let's go to the first question. Calculate the number of photons emitted in 10 hours by 60 watt bulb. Wavelength is 5893 angstrom. Great. So it's an easy question, direct question, easy question. Now what it says, here we'll write power is equals to what? 60 watt. Time is 10 hours, that is equals to 10 to 3600 seconds, and lambda is given as 5893 angstrom. So now energy of one photon, okay, so energy of one photon is h c by lambda, or we can write it 12400 upon lambda in electron volt. Okay, so now we can write it in this way also. So we will do it here upon 5893. Is it almost becoming 6000? Yes. Is it almost twice of it? Yes. So we can take the ratio directly as 2, or there is something more than 2 point something, let's say 2.1 something. Yeah, it's coming around 2.1. So this is energy of one photon in electron volts, and you want to find out number of photons. Number of photons we already did it. Number of photons equals to power upon energy of one photon. So now we'll convert it from electron volt to joules. If you want to do the conversion, it can directly be done like this: 3 into 1.6 into 10 raised to the power minus 19, and it will become joules. Okay, now number of photons is power upon this. Power will be, for 10 hours it is there, so 60 into 10 into 3600 divided by energy of one photon. Energy of one photon comes out to be how much? It comes out to be from this 3.3 into 10 raised to the power minus 19. 3.3 into 10 raised to the power minus 19, and this gives us a number of photons as 6.4 into 10 raised to the power 24. So number of photons in 10 hours emitted by this bulb of 60 watt will be 6.4 into 10 raised to the power 24 photons. That many photons. Next, a plate of mass 10 grams is in equilibrium in air due to the force exerted by the light beam. Calculate power of the beam. Assume plate is perfectly absorbing. Assume that the plate is perfectly absorbing. Great. So this entire mass of the plate is being catered by what? Is being catered by the radiation force. This entire mass, 10 grams of the plate, is being balanced by what? Is being balanced by the radiation force. So force should be equal to mg, force by photons. Mg is what? 10 into 10 raised to the power minus 3, because it is 10 grams into g, we can take it directly 10. In this question we'll take it 10. So this much. Now we did this before, that force, and one more important thing, it has said that assume plate is perfectly absorbing. That means it is taking in all the photons. If it is taking in all the photons, the force will be what? It will be IA by C, right? Or we can write as P by C. So this P by C should be equal to 10 into 10 power minus 3 into 10. C is what? Speed of light. So power is equals to 10 to the power minus 1 into 3 into 10 raised to the power 8. That is 3 into 10 raised to the power 7 watt. This much will be the power of this bulb. Then only this 10 grams of plate will be staying in equilibrium. That much power, 3 into 10 raised to the power 7 watts. Okay, let's go to the next question. Yeah, so now we have photoelectric effect. Yeah, so the question says that in photoelectric effect, the work function of a metal is 3.5 electron volt. The work function of a metal is 3.5 electron volt, and the emitted photons can be stopped by applying a potential of minus 1.2 volts. Then, now this is a very easy, very basic question. If you just know the theory simply, you will be able to crack this question. We did this before, we'll do it now. Energy of photon is equals to phi plus Ke max, which can be written as phi plus EV naught, that is stopping potential, right? So stopping potential has been given as 1.2 volts, right? And here this is given as 3.5 electron volt. So if it is 1.2 volt, the how much energy will it convert? 1.2 volt stopping potential will convert into potential energy. This much potential energy, how much it will be? 1.2 electron volt potential energy. So here if we write EP has to be equal to 3.5 electron volt plus 1.2 electron volt. Now why it is plus and here it is given minus? Because to stop the electron you need negative potential to be applied, but that negative potential will eat up the actual energy of photon. So here in the equation it will be plus. So this comes out to be 4.7 electron volt energy. So the energy of incident photon is 4.1 electron volt. This A option is the right option here. Okay, now let's move to the next question. Yeah, so this question says that which one of the following graphs represent the variation of maximum kinetic energy of the emitted electrons with frequency mu in photoelectric effect correctly. So now this question tells us that this is the relation. Now have you drawn this graph? No, we have not. So let us find it out. So again we'll write the same thing. Energy of photon is equals to phi plus, it is talking about kinetic energy, we'll write it EK, kinetic energy. Now this phi is a constant, this EP is variable according to frequency. We can write it here, H nu is equals to, this phi is a constant, so we'll keep it as phi plus EK. So now we can see here that this is constant. If we increase frequency here, EK will increase, obviously, right? EK will increase, but there will be no EK till the point of time we reach to phi, isn't it? So there will be some frequency which will relate to this phi, and after that there will be kinetic energy. So which graph is showing us this? This is a straight line graph starting from 0. So this is gone because it is starting from 0 and we cannot start from 0. We have something here. This is a graph which is showing that energy is more when frequency is 0. Again wrong. This is a graph which is showing that frequency is 0 but still there is energy. How can it be? Again wrong. This graph shows us that there will be some frequency for which there will be no kinetic energy. After that there will be kinetic energy and it will be a straight line graph. So this fourth option is the correct answer for it. What my point? Again the same single equation which we know, we'll use that and we'll get to all the answers. So the last question for today is this one. The stopping potential versus frequency plot of a substance is shown in figure. The threshold wavelength is important and nice question. It is given what? Stopping potential V0 here, and it is given frequency here. So what it says is that there till some point of time, what? So till some point of time there will be no requirement of V0 for till some frequency. So that means there is some energy which is there which will be required by the metal as work function, and then only we will be needing stopping potential to stop the electron from going to the anode part. Got it? Got my point? If you didn't, go to the experimental part which we studied 2 days back, and in the experimental setup we did this. Okay, so now here it says that on this point, which point, where frequency is 5 into 10 raised to the power 14 hertz, at this point we start having some kinetic energy, so we start having some V0. Now what it has asked? It has asked for the threshold wavelength. It's okay, this is the threshold frequency, right? We'll write threshold frequency is equals to 5 into 10 raised to the power 14 hertz. Now you need to find out threshold wavelength. C is equals to mu into lambda. C is 3 into 10 raised to the power 8. This is 5 into 10 raised to the power 14, and this is lambda. So we'll write lambda as 3 by 5. 3 by 5 is what? 0.6. So we can write it as 6. Because it is 0.6, we'll write, okay, first we'll write 0.6 into 10 raised to the power minus 6 it will become. Now we'll convert this into 1, 2, 3, 6,000. Now we have taken up 4 zeros, so we need to give 4 zeros to this power. 10 minus 10 raised to the power minus 10, this becomes 6,000 angstrom. Okay, this becomes what? 6,000 angstrom. So option B is the correct option. Okay, so now today we are done with some questions as well, and if you face any doubt or difficulties, you can get in touch with me. Thank you.